Now we'll hear from John Gale. John joins us from the IEA GHG as the General Manager for the IEA Greenhouse Gas Research and Development Program. John Gale is responsible for managing the overall program to meet strategic objectives agreed with the members and managing the research program fund to meet members' needs and requirements and the health and safety executive legal requirements for operating companies in the UK. John is also the Editor-in-Chief at the International Journal of GHG Control and has 30-plus years in the energy industry. He has published over 50 technical papers and has worked in China, India, Russia, South Africa, Bulgaria, Romania, currently in Saskatchewan. Now, today, please welcome John Gale.
Thanks, Nick. Okay, I might be something of an afterthought here, but I'm going to a little bit track back and then track forward. Maybe cover a few things that have been said already, but hopefully in a different perspective. Okay, can you all hear me? So, let's work this little duty first. Okay, I call this title CCS, or Carbon Capture in Saskatchewan. Now, I'm going to offend our friends in Norway here. I could have done carbon capture in Norway, but sorry guys, you fell off the lane at one stage. You failed to produce the first pilot, but I had you guys down as bankers at Mongstad, the main plant, but you didn't deliver. So SaskPower has delivered, so it's CCS in Saskatchewan, and I'm really pleased about that. As an organization, it's fair to say we've had quite a long history now with Saskatchewan Energy and Mines, and SaskPower. Our program started in 1991, and one of the earliest members of that was Canada. And at that time, it was Saskatchewan Energy and Mines who were one of the early associate partners, and they were replaced by SaskPower, who came in as part of the consortium group through Canadian Electricity Association. We were greatly honored in 2000 to help with the startup, and then in 2002, the IEA GHG Weyburn-Midale CO2 capture and monitoring program. And our role was there in sort of broad communication, sort of establishing not the facts, but telling the whole world what was going on in Saskatchewan. And we organized quite a few trips in here. We've done peer reviews, international peer reviews on that project. And we've organized some special seminars and at conferences throughout the world. So we've helped promote Saskatchewan and the Weyburn project in particular. I feel like coming home a little bit to Regina. I started working here in 1999. And my first two trips were one to Saskatchewan and one to Trondheim. And my CCS ship for those many years was Saskatchewan, Trondheim. And it got to the point where this hotel, people were calling me by my first name. I don't know whether that's good or bad. But certainly, I've been here. Somebody asked me last night, one of the Chinese gentlemen, how many times was it my first trip to Saskatchewan? And he said no. I said no. He said, how many times have you been here? And I lost count. I can't remember. 20, 30 times? I mean, Mike, you might remember. We've also been associated with SaskPower and the University of Regina through a GHDT conference we organized in Canada in 2006. And we've done a lot of work through our post-combustion capture network, our oldest network. And we've hosted that here at least 3 times. We've had SaskPower involved in that at the University of Regina. So we've been doing a lot with you over the years. And I just wanted to add a few more first and remind people, actually not quite the first, but the first pilot capture plant was built at Boundary Dam with a baghouse, NOx and SOx reduction. Lubbock in the USA will claim to be the first, yes, but it hadn't got NOx and SOx reduction. So this was the very first, and I had pleasure in visiting this in about 2001. Mike, this was actually before your days. Probably not Max's, but certainly before yours. But this was the very, very first, and sort of certainly put Saskatchewan on the path. And of course, then we see the International Test Centre. Now, some of you people in the USA will again say that, they established the first test centre of excellence on CCS, but you can argue that, no, I think, I'd say sort of certainly University of Regina was one of the first, if not the first, in establishing an official test centre, international test centre on CCS. So we're building a whole series of pattern here for Saskatchewan. The Weyburn-Midale project, we've mentioned that several times, and that is the first fully monitored CO2 EOR project in the world. And it's done a lot of good work over the years. And probably one of its best and most notable outcomes was the fact that it established monitoring regimes and this, that, and for EOR that are becoming the standard to date. But also, it showed the benefit of baseline monitoring. When there were the odd farmer or so was rattling around saying that this project leaked, the baseline work done at the Weyburn-Midale work confidently demonstrated to the world that that was not the case. And that put CCS then on the map. It sort of said that, look, these projects do not leak CO2. So all you antagonists, all those who are claiming we're going to have the new Lake Nyos in everybody's backyard, you are 100% wrong, and we've proved it. And that was done here. So great news. What often gets forgotten is this little thing, 350 kilometers pipeline from North Dakota right up here to Saskatchewan. It's the first international cross-border pipeline. I don't know if that really means anything. I certainly wouldn't get away with it in Europe, but okay, is Canada, Saskatchewan a cross-border? I don't know. Okay. Maybe it is, maybe it isn't. Mike alluded to the fact that it's not just a pure CO2 pipeline. It's got a few little impurities in it, about 1.5%, 2% sulfur, a few hundred ppm of mercaptans. So if in terms of challenging to build a pipeline and operate it, those guys were the fun bits. And from what I can understand, those little mercaptans certainly made their mark on the route of that pipeline up here. That you could smell any leakages in valves, and it caused the engineers a few little problems in turning the valves over from conventional to nitrogen gas-based valves, but the problems were solved. It was permitted and constructed without any issue, and I haven't heard anybody moaning about any operational issues on that pipeline since. Mike, do you know of any? Or no? I think it's just ran and it's produced CO2. So another pretty big first, and there's a lot building up here in Saskatchewan. So I think it's only right that the first demonstration plant of its kind working on CCS is built here. You've got a great track record, guys, and you deserve it. So well done to you all. Now this picture, sorry I'm losing my voice a little bit, was taken in May 2014. And I deliberately sort of put that time shot on it because in April 2014, the IPCC in their wisdom issued their Working Group 3 Assessment Report 5 summary, which we think is very negative in terms of technical aspects of CO2. Okay, the policy measures are there, but these guys then went a bit over the board in the script, I thought. They were talking about CCS, and they say the components are in use but not applied at large scale. Industry gets quite a kicking in the IPCC, and I don't know why, because industry has been at the lead of this right from the start. Sleipner, Statoil, Insular, BP, Air Products, Shell, they've been leading this right from the start, and so has SaskPower. So these components are there, and they're a commercial market scale. So why the IPCC can't acknowledge that, I don't know. And the second comment was no commercial scale CCS power plant at the moment. Okay, strictly true, literally true. But wouldn't a fair comment have been at that time to say, there's no commercial CCS power plant in the world, but as I showed you, there's one under construction that's very, very close to operation. So we've been going back to the IPCC and saying to them, why are you so negative about CCS? Why do you sort of deny that these plants are being built? And you haven't yet got a response. That's quite interesting. I think, I'd like to think that they've actually admitted that they need to get their act together and be a bit more positive about CCS in certain respects. Our next challenge is scale up. Whilst we've been slowly demonstrating and building capture plants, the boiler industry, in a sense, has been moving ahead in many parts of the world. And it's not uncommon now to see 1 gigawatt boilers being built in China. I visited a site really in Guangdong in southern China recently. They're in the process of constructing 8 1 gigawatt boilers on that site. And they have designs for 1.25 gigawatt boilers on their shelves and looking to build them. So they're moving along, economies of scale, That's reducing their costs. Coal is very much part of their economy, as it is here. They are building these plants at a rate. The biggest lignite plant in the world is about 858 megawatt. That's Bełchatów in Poland, and they're building big plants. At the moment, we have Boundary Dam at about the 150 megawatt scale. We have Parish now coming on, about 250 megawatts. So we're a little bit adrift. But are we really adrift? We're only talking in terms of a 4-to-1 or 10-to-1 scale-up. That's not really that far out of this thing, and it's well within good and standard engineering practice. So I think these projects set the benchmark now, and once we see these operating well and successful, we are in a good place to scale up and probably expand this technology into places like China. But we're already at the scale, I believe, where we can deploy this in Saskatchewan. They fit with the regulations that are now coming out through the US EPA in USA, a regulated market for CCS, so we're already there. So we've already hit a market area, so that's good news, and you guys have set that benchmark. Going forward, we all talk about reducing cost as the key, and there's a great deal of speculation. I mean, we've seen significant reductions in costs of solar power. But you can tool up a factory in China at low cost and produce 1 billion of these units and throw them out in the marketplace. That's damn easy. But you can't tool up and build 1 million capture plants and put those out simply. This is a different ball game. And the different ball game in here is we're going to reduce significantly the amount of CO2 emissions by introducing this technology. Solar power is going to have a place. It will reduce emissions, but it's not going to solve the problem all the time of when people want to switch their lights on, the electricity is going to be there. Because solar power is variable. We've got to reinforce the grids. You've got to enforce the grids by putting, like in Germany, they're putting in more coal power plant. Other countries are putting in nuclear to make up for that variability in the grids. So we're going to rely on fossil fuels. There's no two doubts about it. Now, we have to get these costs down. The simple route is replication, and we've seen through other technologies like flue gas desulfurization, which this graph shows here, that you go through this curve. The first of the kind plants are over-engineered. We've heard that said this morning. Second generation, third generation plants, then you start to see cost reduction. We could get down to 20, 30, Mike's talking about 30%, brilliant for our next one. That could track us down even further, down to 50%. And I believe if we get down to something like 50% of the costs, we have a good market opportunity for CCS in many parts of the world. There are the purists that want to get us down to 80, 90%. Okay, come on, guys, dream on. That's not going to happen. In terms of cost reduction, I think what's good in this marketplace as well is that we have a very strong vendor basis. If you've only got one vendor in the marketplace, or two, then you're not going to really move the market you're not going to shake the market that well. But here we have something like 20 competitive vendors, all vying for competition at this marketplace. So that in itself is a very healthy market situation, and that competitiveness should lead to reducing costs. And we have one vendor in China who has built, albeit at a much smaller scale, Huaneng Group, they've sort of built plants now with costs, they're talking about 50% less than we're building in Europe and North America. Okay, are we going to see capture plants with made in China build on them? I don't know. But there's certainly a competitive drive from that corner of the world to reduce the cost of capture, which people want to export into that marketplace. It's going to drive down the costs again. So I think it's really, really healthy situation. The next market, that is technology innovation. And we've heard a little bit about this from Max, and there's going to be a panel session tomorrow. And probably the real key in the long term is driving the cost down significantly, and that's sort of looking at what are the new technologies away from amines, possibly. There are purists in the room who say we can never get away from amines. Amines are the only possible sort of opportunity. Okay, we'll take that on board, but I'd like to see more research and more sort of backup from that. And there are programs underway, and probably this is the most well-financed project program. In the US DOE, they have their carbon capture program. And they've set themselves a very ambitious target of looking at developing second-generation technologies that are ready for demonstration around about the 2025 timescale, looking at getting capture costs down to $40 a ton, very ambitious. And they've even gone a step further with these, what they call transformational technologies. They're going to take us down to something like Well, that one says $40 a tonne, but it actually should be about 25, so there's a sort of slight mod on the graph there. Because if the transformations can't get them down from any further than the ordinaries, what's the point of doing them? So typical cocker. And what are we talking about? Well, there's a whole range of technologies out there being researched at the present moment in time. We've got the solvent-based process, we've got enzymes, we've got biphasic solvents, liquids, algaes, we've got membranes, we've got zeolites, we've got carbons, you name it. There's a whole toolkit of different technologies out there, and somehow we're going to have to sort them. Some of these are all working beautifully at laboratory scale, and they're going to have to be scaled up, and some of them are undoubtedly going to fall away as we scale up. But that is really, really important. And this is, again, where I see the next step and where SaskPower is going to play another crucial part. We have what I call the sort of holy trilogy of the International Test Centre Network. We've got the National Carbon Capture Centre. I don't know whether Frank Morton's here, but he's going to talk tomorrow. Test Centre Mongstad, the guys are at the back. And, of course, we have the carbon capture facility that Max is going to talk about tomorrow. All these are going to help scale up that technology, those second and third generation technologies. These are the proving grounds for the future that are going to run in parallel with you guys here at this project, who are going to be demonstrating the longevity, the operational efficiency, everything about first generation CO2 capture and storage. So these two are going to run in parallel, and we're hoping at the end of it we get a very buoyant CO2 capture market and a very sort of strong CCS industry in the next 20 years. One question that we keep getting asked is, can we go any faster? Why are we so slow? Well, the first reason we don't want to go any faster is we don't want a car crash at any particular moment in time. Again, it comes down to perception, I think, and governments tend to think that you can build these things quite quickly without any risk, without any problems at all, and that's naivety. And in my view is we're scaling this technology up at a good engineering practice level. So we're not taking overt risks, but we're doing it right and we're doing it well. And that's the core at this moment in time, because we need to get people on board with this technology, because there's a lot of people out there that are not happy about CCS at all. So we need to demonstrate that CCS is a good operationally viable program and a technology. We've solved some problems along the way already. We didn't know about the solvent degradation issues and amine slip beforehand, but during the scale-up processes, we've largely solved that issue already. So that's a big positive, I think, in this. From what I've said earlier, pipelines aren't a scale-up issue in this. They're not an issue at all. CO2 EOR is good for now, but we're going to have to move beyond that soon, in all honesty. If we're ever going to hit the 2 degrees C target, we're going to have to get into saline aquifer storage, and we have the Aquastore project here, which I haven't mentioned before. It's good to see now that the US DOE research carbon storage program has moved away from just CO2 EOR. They're going back to saline storage as the long-term opportunity for them there. So that's good. But I do think maybe that, in all honesty, it's not the capture process, but it's probably the availability of good geological storage sites around the world that's probably going to be the sort of the rate determining step, and I think actually is the slow step at this moment in time. We're developing capture technology. We're deploying capture technology. I don't think governments are necessarily doing enough about developing or understanding their storage resource. In the North Sea, we're only just starting to, in the UK sector, map our storage resource. Okay. We have a huge, supposedly huge geological storage resource offshore in the North Sea basin. You'd think we'd be doing, if we're serious about sort of capturing and injecting CO2 offshore, you thought we'd have had that sort of tied down a little bit up already, but no, we're still moving ahead on that. And I think if it's anything, it's going to be issues with storage that could hit us along the way. We seem to struggle to get over this bridge that we can store CO2 without any significant environmental issues, that once we put it underground, it stays there. We still seem to fight this battle with the environmentalists that it's going to sprout up or shoot out of the ground at some moment in time. And to be honest, it's like batting your head against a brick wall. I don't know how we're ever going to go off against that. We've got a campaign in the UK coming up with fracturing, about, fracking, okay? So we've got this wonderful campaign called Frack Off, yeah? It's quite Australian in its nature, I think. Now, they have suddenly, they started off as a small pressure group, and it built up with a few liberal activists and this, that, and the other, and suddenly I find that they have a site which talks about CO2 capture and storage. And they're actually going on and sort of talking to people in government about the problems with CO2 capture and storage. And I find that amazing. Now, they're alluding back to Lake Nyos, and everything that we have been talking about is rubbish for the last 20 years, and these guys are back at it again. And I don't know how the hell we get away from that. Maybe the root and grass knowledge base that we see from the CO2 degrees is going to get us through that, but it's not going to get us through that immediately. But it certainly is our biggest battleground. And certainly coming out of the fracking industry at the moment, I think induced seismicity is another one that we need to sort of think about, prepare our defense lines for. Whether that's really an issue with CCS, we don't know yet. We haven't injected the sort of quantities they're doing there. But certainly the public, and again, these wonderful groups like Frack Off, are associating CO2 storage with seismicity by default, yeah? And we need to sort of be conscious of that and be aware of that as we move forward. Because it's little things that are going to trip us over. And I'm going to summarize now, because I'm dying for coffee, my throat's drying up, but I know the rest of you are. SaskPower Saskatchewan have been at the forefront of CCS development for well over 50 years, and I applaud you for that. There's only one other centre, I think, that can agree to parallel that, and that's the Norwegians. You're going to continue in that for the future. Nobody's going to take their eye off you for a while, I'm afraid, because all the other sort of projects are following you or have fallen by the wayside. Mike, I don't know how much it must have cost you financially to buy off these other projects so you were the lead project. Yeah. And I'm sorry, but the eyes of the world are going to stay on you for a long, long time to come. And this project, I'm confident, will be a showcase project for a long time to come. So what we need from you is a successful startup and demonstration, and I say, and that is really, really important. We need that to show confidence in this industry. People are looking for this project to trip up and fail. They'd love to say, oh, look, it doesn't work. And whatever happens, they're going to say it doesn't work. Even if it's a valve failure or something like this, they're going to amplify that, because there are a lot of people out there that don't want this technology to work, whereas we in this room do. And so no pressure, guys, but I'm confident you can deliver. And just a final shot, cooperation continues. Mike has alluded to that, well, agreed that our post-combustion capture series will continue here next year, when we hope to be showing 1 year of successful operation of the Boundary Dam pilot plant, but also looking at focusing on the development of the second and third generation of technologies that will come through this thing. So Max will be looking for your guidance and input into this program. So thank you very much, and enjoy coffee.